I hope my screen is visible.
Yes.
Okay. Good morning, everyone. Before I start, I would like to thank Professor Aprajita Oja and Dr. Neelam Dayal for giving me this wonderful opportunity to interact with you all in the area of blockchain technology. So I work on blockchain technology for last 7 years. So we have done a lot of works, that is the research work in blockchain technology, and we have set up a testbed also, which can be used by any people from anywhere. That testbed completely gives the hardware setup. So in this session, I will be discussing about the basics of blockchain technology. Later in the next session, I'll be talking about the consensus protocols and the digital signature. So we know the importance of blockchain these days. It is getting used in various applications because we want to bring the distributed storage, or we can say the control should be distributed across the participating nodes instead of having it in the centralized node, so which always create a problem. So let's first see the centralized ledger. So in many of the organizations, still we have the centralized ledger concept. So let's consider the ledger is the database. It may be RDBMS, or it may be NoSQL, or whatever the storage it may be. If we have the centralized storage, there will be an administrator. It may be an individual person or set of person, or the organization which maintains that. For example, we can see the banks. Many of the banks are still using the centralized ledger facility because it provides certain advantage. For example, reliability. So reliability in the sense, as we have gone through in database, so there are possibilities of anomalies, insertion, or it may be update anomalies if we go for the normal forms. So if we have the storage which is centralized, so then what happens, the update, whatever happens on that particular database, it may be update or insertion, so everything will be reflected immediately, and when the user access the data, they will get the right data. So it ensures the reliability on the data, whatever is getting accessed. And also it is easy for the administrators or others to do the monitoring as well as the auditing. So even though we say that it is simple or easy for the administrator to do monitoring and auditing, but it is not going to give the transparency. So because of these reasons, like reliability, monitoring, and auditing, so we can say that centralized ledger is perfect to use. However, it has the drawbacks. The first thing is availability. Since it is centralized, there is a possibility of loss of data. So let's assume that we have a single server which is located in so and so place. So it may be that the system get crashed or somebody has compromised. Then what's going to happen is we are going to lose the data completely. And next, it is possible to perform the denial of service. So most of the cases, what people they try to use some DNS server, which may be of Cloudflare, or we can say like Google one. And what is happening these days, the top level, this is just an example, the top level domains, which is going to resolve the DNS, they use the Anycast. So that means they can have their servers with the same IP in different places to ensure that even if denial of service comes, that is the mostly it is distributed denial of service. If the massive number of requests comes, maybe one server will get affected. The remaining may be providing the service to other genuine users. But because we have Anycast, so it is distributed. That's why we could provide the service, or they are providing the service. If we have the centralized storage, if it is getting the massive number of requests from the attackers or from the compromised nodes, then we will be in shortage of availability. That is, the genuine users cannot get the data, whatever is expected. And next is the computation overload. If it is of single machine, so everything will be handled by that single server. So it may not be in position to handle all the requests and provide the service on time. So for example, we can see in machine learning also, even though the federated machine learning was introduced considering the privacy part, but what they say is, instead of doing the complete training on a centralized machine, why not we distribute so that it can be like the computation load will be distributed, and because of that we can ensure the efficiency. So that's what the intention. So similarly, when we are going to distribute our ledger, then definitely we'll be reducing the computational overhead. And next, if it is centralized, we have to trust on the administrator, either it may be for integrity or if we need the confidentiality. But these days we always talk about zero trust. So it is like we have to trust, considering the trusted third party, we are going. But there are certain applications like banks and all. So we always consider that they don't do any modification and go accordingly. However, there are various applications where we need the distributed system concept. So that is the reason the distributed ledger technology was brought into, and we cannot say that it is something new which comes along with blockchain technology. It was earlier also there as distributed systems, what we have studied. So in distributed systems, that talks about the distribution of the services between various nodes or among various nodes. However, how we are going to use it's up to the application. So what the distributed ledger technology is going to bring for the application or the users, the first thing is it will be that the data what is mandatory for the application will get stored in multiple separated devices. It may be within the region or it may be located in different places. And we have to ensure it gets synchronized. Otherwise, we will be getting the anomalies like insertion and updation anomalies. And all these nodes or devices, whatever is going to perform the distributed operation, all should connect into a network and it gets synchronized so that we can ensure the availability as well as the accuracy. So here we don't need to worry of the single node compromise or loss of data due to a single node crash. So because it is distributed in various places, it can be accessed from anywhere. So it ensures the availability as well as many parties are involved. We can say the integrity of the data is also getting ensured. So that's the accuracy. So blockchain technology is a distributed ledger which ensures that all the participating nodes will have the copy of the data, whatever a single node is having. And the data, whatever is going to be distributed, that is going to get organized in certain form. So that form we referred is the blocks. So the data is organized in the form of a block. So it won't follow the, for example, relational database management system. It follows its own structure. It uses the Merkle tree to store the representation or to have the data in that Merkle tree form. Or we can say that the data is kept in the Merkle tree form. Even if we see RDBMS, whether it is MySQL or Oracle, those also uses the B trees or its variants to store the data. However, when we go for visualizing the data, it represents in a form like a table. So in case of blockchain, it keeps the data in the Merkle tree. And if we see the difference between the RDBMS and the blockchain data storage, so it is more efficient, we can say, access the data or store the data in case of relational database, even user visualization also. However, in case of blockchain, it is little complex. So we cannot directly go and access. So such kind of drawbacks are there, but that can be overcome based on whatever implementation we are doing. So if we see the Bitcoin and the Ethereum, so Ethereum is having a different structure. So using that, we can find out the account balance of any person by just looking at the latest block. However, in Bitcoin, even though the implementation setup is something different because it works based on the transaction, we'll be seeing that now. There you have to traverse the complete chain to find out what are the transactions made. So like this, there are, we can say, the efficiency drawback between the relational database management system and the blockchain storage. However, the blockchain is going to bring the distributed ledger as well as going to ensure the integrity of the data. So the integrity is brought because the blocks, the blockchain is sequence of blocks, and the blocks are getting connected with one another cryptographically. So if we have to change a block, then it is very much necessary to change the another block, and because that another block is getting changed, so we have to change another block. So this will be keep on going, and I hope my slides are visible. Is the slide visible?
So it is visible.
Oh, okay, because someone said that to share the slides, so that's okay. So the blocks will be keep on, the blocks are connected cryptographically, and if we have to change in one of the blocks, then we have to change the sequence of blocks, and that is very complex to do. And the clients connected into the blockchain network will have the exact copy of the blocks. So there will be n number of parties who is taking active role in the blockchain application, that particular application. All of them will be having the exact copy of the data. So we cannot say at any point of time t, all will be having the same data. For example, in T1, let's say the client 1, client 2, and client 3. So client 1 and 2 may be having A, B, but client 3 will be having only A. But if we see at time T2, which is increasing in this order, the client 3 will also be having B. So it's like all of them will be having this exact data. However, there will be a delay in having the exact data. So that's what happened because it is the distributed network, and the people has to forward the messages, and definitely there will be a little delay in getting those messages. And these days, blockchain is used in various applications, as I already said, because it ensures that the data, once we put, it is very, very less possible to modify the data. So even though in various forums or in the articles we can see is like it is not possible to modify, but we have to consider that it is possible, but it is very, very hard to do that. The reason is, for example, Bitcoin, it uses the proof of work. If I have more than 51% of computational power in the whole network, then it is possible for me to modify the chain. So in that case, we can say, yes, it is possible to modify. But having that 51% of computational power is very, very hard. So it's like a person with rest of the world or a set of persons with rest of the world. So it will be very complex to bring. And even if you start your own chain, it is not possible because it's already grown very long. It is not possible to replace the chain. So similarly, if we apply into any enterprise applications also, the same problem is the complexity is applicable for the attackers to make the modification. However, we have to see in case of enterprise applications, we need certain changes. In case of cryptocurrency, we give rewards or the transaction fee that encourages the nodes to actively participate. However, in enterprise applications, we will not be having such things. So then how they will take the participation? We have to bring the voluntary participation. which is very complex because the world is the business world. So this is sample representation of the blockchain, how the blocks connected and the data are stored. So this is considering Bitcoin because the other implementations, so we can see this as a block which contain two parts. One is the header and another is data. So let's say this as the data part and this as the header part. This representation, again, I repeat, considering the Bitcoin, because if we see in Ethereum, it has more parameters. So it's according to us what the implementation we are doing. So according to that, we can add more parameters. So in our case, we modified the Ethereum and we inserted some more additional parameters. However, we have to see how much parameter we are going to keep in the header so that the storage efficiency is also very important. That I will be discussing in the next session. So it contains the previous hash. So for example, this previous hash refers the hash of this complete block. So the hash is the cryptography hash. So that is computed using SHA-256 algorithm and that gets stored here. Now, if I make any change into this place, then I have to change here. If I have to change this, I have to change this. So it will be keep on going. So it's very, very complex to do. It's like replacing some of the blocks, which is very, very complex in the network to do. And we have the timestamp as another attribute. So this is common in any of the blockchain implementation. So which represents the time at which, this is the Linux timestamp, the time at which the block is created. And the nonce is there. This is considering the proof of work, which will help in solving or verifying the proof of work solution. So this will discuss when we are going to discuss about the proof of work. And next is the transaction root. So in blockchain, all the activities are done through the transaction. So let's see that we have the transactions 0 to 3. These are, we cannot say these are the leaves. These are the pointers to the leaves. And this is the representation of the Merkle tree. So the transaction hash is stored in the leaf. That is hash 0 is the hash of transaction 0. This is the leaf of the tree. And this value is the pointer to this. So the implementations, for example, Ethereum uses the level DB, which is of the Google product. So every location is identified as the hash pointer. So it ensures indexing as well as it ensures the integrity of the data. So like this, for all the transactions, the hashes are computed. Now, these two hashes are again concatenated and hashed in the next level. So similarly here also, and finally, these two hashes are concatenated and hashed, and that is placed in the transaction root. So now when the previous hash is computed, that is the hash of this block is computed considering only these values. It won't consider. So now this hash value is placed here. So we can say that if only these are considered for computing the hash, then attacker may modify this. That is not allowed, because if we make any change, this is going to get changed. If this one is getting changed, then the hash is going to get changed. So that's the reason it's not possible to modify. So we have header part as well as the data part. There are nodes which can store only the header part, and there are nodes that can store both. So it's according to whatever the computational infrastructure it has, accordingly it will go. So there is a question. So where can be the use tree structure if we have network of, so it's like this representation will be with each and every node. So this is the chain which I will be having, you will also be having. So if let's say 1000 node or 2000 nodes we are having, for example, I'm going to maintain all the 10,000 nodes, the tree will accordingly get bigger. Okay. So what feature the blockchain brings, since it's part of the distributed ledger, so it is going to bring the decentralization and integrity of the data is maintained. So definitely we can say that so maybe the whatever questions given in the chat box, I will take at the end. Right now, let me go for the slides. Blockchain ensures the integrity of the data, since it is getting distributed as well as the blocks are getting connected cryptographically. And next is it is publicly verifiable, that is anybody can verify. However, it's based on the implementation, whether that particular implementation allows the public to verify or not. So this we will see different types of blockchain, how we choose for our application in the last slide. And next is it ensures the availability because it is distributed. Because of all these above, the application is going to bring the trust. So that's the reason people are very much interested or focused on applying blockchain technology into their applications. So if we see the network, normally we have these three: centralized, decentralized, and distributed. So in case of this, as we are discussing about the centralized ledgers, so this is not getting used. And next we can see the representation in the form of decentralized. So here in case of centralized, we talk about the failure. It's like if this node get compromised or it is not available, then the entire network will be down. But if we see here, it is not like that. So if this node is going to get compromised or it is down, only these parts get affected, not all of them. So similarly here also, even if this link is down, this particular subnet will be getting the service through this place. So this is decentralized. However, the blockchain follows this representation, which is distributed. So there are places they say that it is decentralized in the form of ledgers, but the nodes are connected in the distributed manner. Because see, there are two things we can say. When I'm going to join into the network, it is up to me how I am going to connect. However, there is an advice that you should always have more than one neighbor. Even Ethereum says you should have minimum 7 neighbors to overcome various issues. So if we see in this particular distributed network, we cannot say that it will be like completely one will be connecting with all others. That is not possible in the entire worldwide network. So it is possible that we can connect to our neighbors. For example, if this link is down, this particular node is having the position to connect with these two through these two nodes. Even if this is down, then the position this node is in position to connect with the network through this node. So this is the advantage when we are going for the distributed connection or distributed network. So because it is connected in that format, we always ensure the availability, that is we are part of the network, and no need to trust the single entity. Because if we see in this, these nodes should connect to this node, and all this has to trust this. But in case of distributed representation, it is not that. We don't need to trust only one. There are multiple nodes to whom we are connected. So if one fails also, there is no issue. So this says that chance of isolation is very, very less. And there is an attack called eclipse attack, which I have added in the end. So let's see that how that is possible, that attack is possible. So the attack is called as eclipse attack. Now let's say that this particular guy is getting connected with 1, 2, and 3. Now it is possible that these 3 nodes are the colluders. They know each other, and these 3 are the attackers. And now this particular node, let's say Alice, is connected with them to connect to the network. So if Alice want to connect to the network, only these three guys are there to connect. So if these are, let's say, colluded and they are against Alice, what is going to happen? Now Alice is like isolated. If Alice is sending anything to the network, it will not go to the network because these guys are covering Alice. And if something is coming to Alice, that also they won't give. So this is what represented as the eclipse attack. So let's see the solution later stage. So we have different categories of blockchain implementation or blockchain development. So one is like permission. So when the Bitcoin was introduced in 2008 by anonymous Satoshi Nakamoto, it was considering only the permissionless. So there was nothing like permissioned hybrid or private permission or public permission. There was nothing like that. So the Bitcoin was introduced completely considering the permissionless blockchain technology. And even there was no name given, I can say. But later people realized the importance or the significance of the blockchain. So then they thought, let's bring it to the private permission, to the enterprise applications also. So they brought the permission and consortium and the hybrid base. So in case of permissioned blockchain, there will be always an administrator who will allow the participating nodes to join into the network. And they communicate with each other, considering the credentials, whatever they received from the administrator. But in case of permissionless, we don't have any kind of administrator. Anybody is allowed to join into the network. So whether they are known to you or not known to you, they will join. So for example, in Bitcoin, Ethereum, or any of the cryptocurrencies, anybody can join into the network. So it provides the facility to allow anybody to join, which gives the anonymity for the users. So we cannot say it's completely anonymous, it's pseudo-anonymous. The reason is they may be tracked using their IPs, or they may be reaching the exchange office. So in those cases, they may be identified. So that's the reason we say that it is like pseudo-anonymous. But it has the drawback also. Since we are allowing anybody to join the network, so we may be allowing the attackers also to join the network. So even though attackers are joining or taking part in the network, the application is in position to provide the genuine service. So that's the significance of the blockchain technology, why people want to use in various applications. So in case of hybrid, they combine this permissioned and permissionless. And next is the consortium. There are multiple organizations that come together and develop the blockchain technology and use only for their organization. For example, CODA is the consortium blockchain technology. So now let's move on to the Bitcoin. So the blockchain technology, the word comes with the Bitcoin. I cannot say that complete blockchain technology is new along with Bitcoin. So there are claims, as you can also see from Wikipedia. It was proposed very long back. Even in 1970s, also the similar representation they claimed was proposed. However, it was very popular from 2008 because the money is involved. So the Bitcoin is the cryptocurrency which is permissionless. It allows any users to participate in the network, and it uses the proof of work concept. So which is considered as the consensus protocol. Actually, proof of work is not the consensus protocol. This protocol is to control the growth of the blockchain. So control the growth of the blocks. Otherwise, if we don't have this problem solving, then there will be numerous number of blocks get created and the forks will be enormous. So to control that, the proof of work is introduced into the Bitcoin implementation. So since there is a delay in creating the next blocks, that delay is utilized to ensure the consensus. So that's what happened while using the proof of work. So we will see in detail how proof of work works. That will be in the next session. So the underlying technology for the Bitcoin is it uses the network and it uses the distributed systems, which is built on top of the blockchain. So we can say Bitcoin is the application of the blockchain technology, and blockchain is the application of network or the distributed system. So blockchain technology uses the network, distributed system, data structures, and cryptography algorithms. So how the Bitcoin is getting processed? It is getting processed as transactions, not as account balance. So let's see these two things briefly. So what the account balance is, for every user, let's say Alice, Bob, and all other users, they will be having their account numbers. So in case of blockchain technology, we will say that this is the transaction address or the address of the person. So same will be there for all. However, not the same account number. There will be unique number for each and every user, and the balance. So Alice will be having X, Bob will be having Y. It is like that. Now, if Alice is making a transaction, that is sending a balance from one account to another account, that is Alice is making a transaction to Bob. For example, so 10 BTC or Ether Alice is making. So now what's going to happen? The balance will be subtracted here and it will be added here. So accordingly, this gets updated. So this works based on the account balance. So this process is called account balance based processing. So if the balance is not sufficient, then it will not be it will not be possible to make the transactions. Similarly, if the account is not present, then it is not possible to make the transactions. So this account balance will be keep on updating based on the debit and credit. So everything will be subtraction and addition. Next, in case of transactions, there is no concept of balance. So let's say Alice, Bob, there are initially the money is getting introduced into the network in the form of coin-based transaction that we will see in the coming slides. Let's consider that there is a transaction 1 with Alice, which is of 10 BTC, that is available with Alice, and there is a transaction 2 that is with 5 BTC. So Alice is having the transactions. Now Alice is not having the total. So that is the balance, account balance is not maintained. Alice is having only the transactions with his transaction pool, which is considered as UTXO. That is unspent transaction output, which is available with Alice. Similarly, the same is available with all the participating nodes. So every participating node, that's the active participating node, which will be contributing to the growth or the liveness of that particular application, will be having this UTXO. Now, let's say that Alice is having this data. Now, consider that there is a UTXO which is maintained by Bob in its own storage. That is also having transaction 1 of Alice, which is 10 BTC, and transaction 2, 5 BTC. And in case Bob is having his transaction, that is also be available. Similarly here, so this is of Alice, this is of Alice, and this is of Bob. So all the participating nodes will have the copy of this. As I said in the very beginning, with a little delay in having the accurate data. So these are considered as unspent transaction output. That means these transactions are not yet spent by the particular account holders. So now, if I want to find the balance of Alice, then I have to go through all the transactions and count the total. So then only it is possible for me to bring out the total. So like in account balance, we are not storing the complete balance, subtraction, and addition, that is credit debit, is not going to happen. Everything is stored in the form of transaction. Now let's say Alice want to make a transaction to Bob, which is 12 BTC. Alice want to send 12 Bitcoin to Bob. What's going to happen is Alice will be spending this transaction as well as this transaction, because Alice is not having any transaction with her which is of 12 BTC, and she cannot do the exchange. That is, we can give 100 rupees and take 200 rupees. So that's not allowed. So if you have to do that, you have to make a transaction. So for that, you have to pay the transaction fee. So they normally don't do that. And this also avoids the denial of service attack. So now Alice will be sending these two transactions to Bob. Now these two transactions are considered as spent transaction. So these two will be removed from Alice database. So that means it will be removed from the UTXO. So all Alice, Bob, everyone, because once the transaction is getting distributed to all the participating nodes, they all will remove this 10 BTC and 5 BTC transactions from their UTXO. Now the new transaction get added into the UTXO, that is this 12 BTC to Bob and the remaining 3 BTC to Alice. Now you see there are two new transactions getting created. This is to Bob and this is to Alice. Now Alice is spending these two transactions and stating that 12 BTC will go to Bob, remaining 3 will go to her account only. And it is suggested in Bitcoin, for every transaction we should use the new address, so that nobody will be in position to completely track you to find out what is your account balance and what transactions are with whom you are making the transaction. So this is the way the transaction way of processing works. So transactions and account balance way of processing, Ethereum does account balance and Bitcoin does the transaction based. Even IOTA is also doing transaction based. So this is the transaction of Bitcoin. So however, the things are keep on changing. There are a lot of works happening in the network. They are modifying it. This we took long back. So let's not consider this version flag, those things, because this represents which version of the Bitcoin we are using. Now it says that input counter. So how many input transactions we are going to spend and how many new transactions are getting created. Now, this is the old transaction. As of now, let's say this part is not there. We consider this is part 1 and part 2. Now, part 1 is not yet created. So we consider that the part 1 is part of the UTXO, that is unspent transaction out. So this can be spent by the respective owner. For example, let's consider this is with Alice. Now, this contains two parts. One is the input part and the output part. So this is considered as unspent transaction. This is considered as the spent transaction, which is already spent. Because of this transaction only, we are creating the new transaction. Now, let's see on the right side, that is part number 2, where we are going to spend this transaction. Let's say there are two input output transactions here. One is index 0 and index 1. Let's say transaction 1 and transaction 2. So this is having 5 BTC and this is having 10 BTC. Now, there is a transaction going to happen between Alice and Bob. Now, Alice is going to send 5 BTC to Alice. Now, if we see, okay, consider that this as 10 BTC and this as 5 BTC. So now there are two unspent transactions, 10 and 5, and we have Alice has to send only 10, so only 5 BTC. So no need to touch this. Now she will take this transaction, which is this. Now this will be the input transaction for the next transaction. because now based on this only, that this particular transaction only, new transaction is getting created, and what is happening, the ownership of this 5 BTC is getting changed from the Alice to Bob. And now why this link is happening, and definitely this link will also be there. There will be a chain which will be keep on going up to the initial where it was introduced. So this will help in identifying whether whatever so and so is spending is the proper one. That means is he or she is the owner, or the actual coin is available or not. So we can track this chain and we will find out. So they cannot introduce or they cannot spend someone's coin on behalf of them, because definitely there will be a signature involved and the chain is present. So just like that, we cannot introduce any coin into the network. So now this becomes the input, and the new transaction is getting created, that is the output transaction. So input transaction is considered as the spent transaction, output transaction is considered as the unspent transaction. So from this input transaction, there is only one output transaction getting created, that is this one. Now this will be part of the UTX. So in case, let's say this is 5 BTC, but we have to send only 3 BTC. What is going to happen is, this output counter says it has 1, then it will be 2. So one transaction will go to Bob, that is 3 BTC. Another transaction will go to Alice, that is the 2 BTC. And we can see there are witnesses and the log time. Actually, what is happening when the Bitcoin was introduced, the complete transaction, including the user signature, that is the owner making the transaction, his or her signature is part of it, so that we can ensure so and so is spending the coin, not others. That signature part is consuming more storage. So, and every block can have maximum certain number of the block size can be like something maximum fixed. You cannot go more than that. And because we have the signature, what is happening is it consumes a lot of space. So what they have done is they brought a concept called segregated witness. The signature part they brought separately, which will not be computed while we are considering the size of the block. So this allows more transactions to be added into the Bitcoin, so that we claim that the transactions are getting committed very fast and it handles more transactions. So that's why this witness part is like segregated witnesses, that is the signature is separated out, and this is the log time. So what this says is the output transactions, whatever presented here, it cannot be spent up to this log time get expired. So for example, we go for the fixed deposit in our bank. So for a period of time, we cannot spend that. So similarly, let's say this transaction is committed into block number 10, and we say the log time is 50. That means till the block number 50 passes, we cannot spend this transaction. So that facility also we are having, but this is right now is getting used for the Lightning Network. So this is the Bitcoin transaction, and it get the process of creating the new transactions. And the transaction confirmation, the problem with Bitcoin or Ethereum is, we normally say if this is the block header and the data part, which is in the Merkle form. Once the transaction takes part in this, we say that the transaction is getting committed into the block. So that means that the transaction is successful. We can spend that transaction, but we should not spend. The reason is the protocol, the consensus protocol getting used here is, again, I repeat, proof of work is not the consensus protocol, but we call it as consensus. So since the consensus protocol, which is proof of work, that is going to give, or the proof of work is the probabilistic consensus protocol. So there is no guarantee that this block, which is included in this the block that have the transaction in it is not guaranteed that this will be part of the main chain. So we say that the blocks are keep on going like this. We'll discuss this in detail in the consensus part also, but just briefly I will tell. So the chain will be going like this, but there are possibility that, so this is referred as the 4. The chain may go like this. Now what happened? The sequence, that is the chain which is having the longest, or we say the longest chain is considered as the main chain. So here if we see, this contains 6 blocks and this contains 7 blocks. So now the main chain is this one, not this one. So it is possible that my transaction which is added into this block has gone as a fork, not as a main chain. If there is an action taken on the transaction which is added into this block, that is getting null and void. So for example, let's say I order some product with Amazon, and I do the Bitcoin transaction, the BTC is committed into this block. For example, let's say now Amazon immediately acted on it and it sends me the product. It already started sending me the product. Anyway, they can stop in between also, but let's say that it started sending and it reached me. Now what is going to happen after certain number of blocks? We see that this part is not going to give any use. Only this is going to be successful. And now whatever transaction present in this particular block is considered as null and void. However, Amazon has already sent me the block, sent me the product. Now what's going to happen? Amazon will be into the loss because the transaction, whatever is getting committed into this, is not going to be valid in future. So that's the reason what Ethereum as well as the Bitcoin that says that if a transaction is committed into the block, we have to wait for a certain number of time to ensure that that particular block will be part of the main chain. So this is based on the practical analysis, whatever is happening with Bitcoin. It says that now let's say I have committed a transaction into a block, or let's say my transaction is committed into a block. Let's say the block number 1. Now, if I am going to act on it, this is the minutes. This is considered because we know the average time of each block in case of Bitcoin is 10 minutes. If I am going to act on that particular transaction, which is added into the block number 1, now block number 2 is introduced. There is guarantee that around 63% of probability we can say the block number 1 where my transaction is part of that will be considered as the main chain. That is only 62%. So then if we are coming to 30, that is next 3 blocks, we can say around 91% we can say that it will be part of the main chain. However, if it comes after the 5th block, that is the next 5 blocks, then we can say more than 99.9% it will be part of the main chain. So they always say we have to wait for next 6 blocks so that we can ensure that that particular block which contains the so-and-so transaction will be part of the main chain. So there will be a waiting time. This is the problem which is now creating issue in using the blockchain technology in various banking applications. This is only possible when we are using the probabilistic consensus protocol. However, this is not applicable for the absolute consensus protocol. And Bitcoin gives the reward because we know the proof of work is very complex problem to solve. And if we don't give the reward, normally people will not do the problem solving. So they started with 50 BTC in the beginning. So and every 4 years they are reducing that, they are offering it whatever they have given initially 50, 25, 12.5 and 6.25. Now it will be like 6.25. So later it will be like 3.6 also it will comes like that. And now what is going to happen? So I said 3.6, actually it's 3.1 we can say, or 3.13. So it will be going down. So if we see, the reward is coming down. At one point of time, the reward will be zero. If the reward will be zero, nobody will be interested in doing the proof of work, that is solving the puzzle. So we need some encouragement. So what will happen is, that time the transaction fee will be getting increased. So now itself, if we see, if I put a transaction, it won't be taken by the miners, the one who is going to create the blocks. They will not take it immediately. The reason is, they will see what is the transaction fee I am going to give. If I am giving more transaction fee, then my transaction will be taken faster. It will be taken quickly, because the miners are going to, the one who is going to create the block will be getting the transaction fee. So a person who is creating a block, that means taking a transaction and creating a block and distributing to all the participating nodes, will be getting two fees. One is the mining fee, which is called the reward, that is for creating the block, and next is the transaction fee. So the mining fee is fixed, which comes from this, and the transaction fee is based on how much we are giving for any transaction. So how the transaction fee will be determined in a transaction is, for example, there is an input transaction which is of 10 BTC. Now we are creating output transaction out of this. We say 5 BTC to Bob, 3 BTC to Alice, that is back. That's it. Now you see, the input is 10 BTC and the output transaction is 8 BTC. That means the 2 BTC is going as the transaction fee. So now the miner who creates the block, they will see this count and they find out that 2 BTC is the transaction fee. So the transactions will be ordered considering the transaction fee. If it comes in the top, then this will be taken for commit into the block quickly, otherwise it will be delayed. So let me tell how the transactions or block get broadcasted. So let's say the nodes are connected like this. Now, let's say this is Alice, who makes a transaction 1. Now, once she makes the transaction, she forwards the transaction to these two parties. So now, that is whoever is connected. Now this transaction 1, that is of transaction Alice, or Alice transaction getting transferred to these nodes. Now they will be storing in the transaction pool. Then they will be transferring this, that is forwarding the transaction to the next node. And then further it gets forwarded. So now all of them are having the transaction. So it's like the transaction is forwarded from one person to another person, and that person will be sharing with their neighbors and their neighbors. So slowly the entire network will be getting the transactions. So now at one point of time, we can say all will be having the transaction 1 of Alice. So in the same way, if Alice is creating a, let's say, a block that is also forwarded to the neighbors, then their neighbors will forward further, but they will forward only if the transactions or the blocks are valid. Otherwise, they don't forward. So this is the way it's getting transferred. Now, for example, this particular node will be having so many transactions which are created and distributed in the network. So it will be like this. Now, if this person is going to do mining, that is creating the block, then he will look into, or she will look into this pool and sees that who is giving more transaction fee, and those will be taken and commit into the block. So the transaction fee is like what the transaction is giving, that is based on this, we will compute the transaction fee. However, the reward, that is the mining fee, mining reward is not like variable. It is like fixed. For example, the first 4 years, they say it is 50 BTC. If we mine the block, by default, 50 BTC will be getting. So this is the place where we are introducing the new coins. And after 4 years, the mining reward from 50 BTC to 25 BTC, it has come down. So all the blocks, whatever is getting created, so that will be gaining 20 BTC, then 12.5 BTC after 4 years, after that again 6.2. So the mining fee is fixed. However, the transaction fee depends on the owner of the transaction. Sometimes they don't give the transaction fee. In that case, the transaction will not be taken to commit into the block. They have to wait for a long time. But later they have introduced a concept called a transaction age that we'll discuss. So to participate in the network, we always need the account number or address, we can say. As in the very beginning, I said, if we want to go for a bank, there will be an account created for us. And that account will be identified through the account number. So similarly, in Bitcoin also, we can participate using the Bitcoin address. So how the address is computed is like a person who want to have account into the Bitcoin or any cryptocurrency network, they have to generate the key pair, that is the private and public key pair, which will be used for proving the ownership. So now using the public key, the address is derived. So the public key is getting hashed using SHA-256 algorithm. And again, that output is one more time hashed using some other algorithm, which is RIP EMD 160. So that produces the 160 bits output or the 20 byte output that is given to base 58 encoding, and whatever getting produced as the output, now that becomes the address. So if we see, the address is derived from the public. So anybody can validate the address because we will be getting his public key. Once we get the public key, so we can find out whether this address is getting derived using the public key or not. So one thing we can see that it is hashed twice. In case of Ethereum, that will be discussed maybe in coming sessions by other experts. So it is hashed only once. However, Bitcoin is hashed twice. So Bitcoin was introduced in 2008, and there was an attack or vulnerability which is called as length extension vulnerability or length extension attack, which is possible on Merkle-Damgard construction. And that construction is used in many of the hashing algorithms, including SHA-256 of SHA-2 family. And considering that it is not written clearly anywhere, but I did some analysis, then I assumed that this might be the reason. To overcome that length extension attack, it is hashed twice. However, 2012, the sponge construction was introduced. Considering the length extension attack in the Merkle-Damgard construction, they come up with the sponge construction that is getting used in the SHA-3 version of the hashers, or they say as the Kechak family. So there it is used, and that algorithms are used in the Ethereum. So there is no possibility of length extension attack. So they are hashing it only once. And so using this address only, the nodes get participate in the network. This is also considered as the transaction address. However, I said already that there will be so many address for every individual, because whenever we make a transaction, it is always advised to have different address. So in that case, if we see, they will be having more number of key pairs, and it is very complex to maintain that. So what they will do is they will be having a root secret or master secret. By using the counter, they will be creating more number of key pairs, and that will be kept in the wallet. It may be the hot wallet or the cold wallet. So wallet, anyway, that we'll be discussing in coming slides. So the coin-based transaction. So as I said that the mining reward, whenever it is getting introduced, that is considered as the new coin getting introduced into the network. So that transaction, because everything is in the form of transaction, so we say that transaction as the coin based transaction. So we have seen the transaction. Any transaction will be having the previous transaction, that is the parent transaction, similar to the block. But if we see the very first block, which is considered as the genesis block, so this block is having the parent as the genesis block. Next one is having parent as the genesis block. But anyway, genesis block is not having the parent. So what will be in that field, that hash? So they have taken certain message, and that is considered as the value. And for that, the hash is computed, and that hash is present in the genesis block as a parent. So similarly, when a new coin is getting introduced, there is a transaction created. This is input part and this is the output part. Output part says, just a second, please. Output part says that the coin, that is the reward, is going to the particular account. That account is whoever is the miner. However, there is no input transaction. And the input transaction parameters will be having a hash. And we don't have the input transaction. So for that, it's like these values are a hash, and this is put into the input hash parameter value. So this is something long back which happens in London. There was a news article, the headline was given like this. When they were facing certain issue with their bank or the economy. So this is what called as the coin based transaction. When we are introducing the new coin, that refers as the coin based transaction. And this will be always the first transaction in the block. For example, if we see these are the list of transactions in the block, this transaction is considered as the coin based transaction. That is, very first transaction will be considered as the coin based transaction. And next is the transaction age, which will help in committing the transactions which are not giving the transaction fee or the less transaction fee. Let's say there are thousands of transactions at time T1. Now, a miner can take only 500 transactions. And definitely miner will pick top transaction fee transactions, and 500 is taken, remaining 500 will be there. In the next round, even the transactions are not having the same miner or other miner also, even if this 500 contains a transaction which is not having the transaction fee, that will also be taken for commit. But what's going to happen meantime, new transactions are going to come and that will get added with this. Again, they will see what are the transactions giving more transaction fee, that will be added, another 500, remaining 200. And it may be possible another 500 comes. So it will be keep on going. And there may be a transaction by some, let's say, person call, which is not having the transaction fee, that will be never taken to commit into the block, or it takes very long time to commit into the block. So that's the reason they have introduced the concept of transaction age. In a block, let's say if we are going to add 10 transactions maximum, and it is given that out of 10 transactions, 2 transactions should be the transaction which is already aged. Aged means, let's say I put my transaction when the block number 10 was introduced, but the same transaction is still pending up to block number 20. So B1 to B20, and the age will be computed using an equation or a metric, whatever is given. So up to this time, the transaction is pending. Now, after this, it is considered as the transaction is aged, and these transactions should be taken into the block, and out of 10, certain percentage, for example, 2 transactions should be the aged transaction. So what happened, even though we are not giving the transaction fee or giving less transaction fee, our transactions will be committed into the block. It takes some time, but it will be definitely committed. And another problem is there will be so many transactions which comes with less transaction fee. So that is also getting increased. Now what happened, the age is computed, how long you are there. Okay, the transaction age, the computation output, which is having the more transaction age, that has to be taken in the sequence, so that any transaction will not wait for long time. So this is also like introduced at the later stages. So what mining is the one done by a particular node, or all the nodes will be trying to do the same, but definitely one will be succeeding. The reason is only one block will be part of the main chain, not all the blocks, whatever is generated for that particular number. So what is the role of the miner? He generates the block. So generating the block means confirms the transaction, whatever transactions getting distributed. It checks whether the transactions are valid, and that blocks gets those transactions get added into the block. And for creating the block, that is why it is called as mining. We are going to solve the puzzle, and while solving the puzzle, we have to find out certain value. That is, we are digging to find out the value. So that's why they call it as mine. So for that, the miner will be getting the reward and the transaction fee. And there are blocks which are called uncle block or the stale blocks. So these are the blocks considered as the part of the fork. So block with same number. For example, now the network is trying to construct the block number 10. There are multiple people working to create this block or mine this block. It is possible that more than one person has mined the block, and block number 10 is mined by more than one person. Now what's going to happen? Only one block has to be part of the main chain, remaining will go as the fork. So that is referred as the uncle blocks. So if our block is the uncle block or the stale block, or it is a fork, we are not going to get the reward. For example, we can see this is the chain. For example, the chain is going like this. This is the main chain because this is the longest chain. And now if we see block 1, block 2, block 3, and for block 4, see even block 2 also, there are 2 persons created, that is 2 different blocks. And for block 3 also, there are 3 miners mined the block, and block 4, there are 4 have mined. Let's say that this is the block mined by me. Now what happens, since I have mined the block, I myself had the reward as the coin based transaction. For example, 50 BTC I have added into this block. So then what is going to happen? There is another person also created. Now the block number 5 comes. Somebody considered my block as the parent block, and he or she has created block 5, and they also got 50 BTC. Now you can see this, there are 2 block 5 created, one considering this block 4 as the parent and this one as the parent. Now block 6 get created, block 7 get created. However, in this particular sequence, there is no 6 and 7 get created. So now what happens? The chain is going like this. So this is considered as the main chain. This is considered as the fork. Now whatever 50 BTC I have added into my block, that is considered as null and void. The reason is this is not accepted by the majority. So even though I put my effort, I am going without any reward in this. It is like my effort is gone on vain. So not only mine, this one also. So now whatever the reward, that also I don't get, and whatever the transaction fee, that also I don't get. the owner of this block will be getting this. So this is the major problem with Bitcoin. So what is going to happen is, if like this, I am mining many number of blocks, I always considered as the fork, what is going to happen? I will get discouraged. Once I get discouraged, I will not be doing mining next time. So slowly people will close mining. At one point of time, certain group of people doing the mining. And what is going to happen? The entire network will be in their control. So they can play anything, because if the miner, that's why I said, if the more than 50% of the hash power is with a certain person, with an individual or a group, then they can control the entire chain. So considering this, in case of Ethereum, they have introduced the ghost protocol, that is greedy, heaviest observed subtree. They are giving the reward for the people whose block getting as fork also, but that facility is not there in the Bitcoin. So I'm not sure now, because there are updates keep on happening, whether they are introducing or not. But in Ethereum, at the time of introducing the implementation, they have introduced this concept so that we can encourage the miners. So this is going to increase the security because of the ghost protocol. If we give reward for these 4 nodes also, they will get encouraged in mining the blocks. Otherwise, they will come. So this happens once, I think in 2012 or 13, it's between 12 to 15 it happened. There were very limited number of miners and they belongs to certain countries. So the founders were very much disturbed and they requested other participating nodes also to do the mining. So the Bitcoin wallet, as I said, it's the digital wallet. So instead of keeping our money, we will be having the key. So it may be the cold wallet or the hot wallet. So hot wallet is always like it's connected with the internet. However, if the wallet is compromised, then you are lost. Anybody can spend, because the spending of the coin is based on the private key. If the private key is lost, then it can be spent. And another thing, if we lose the private key, then we cannot spend that. So as I said about the centralization problem, considering that the Bitcoin is not giving the reward for the miners whose block is getting as the fork block. So what is going to happen? This is going to bring the centralization problem. The reason is many will be stop mining because they put a lot of effort, because the infrastructures they have to create is huge for solving the proof of work. So that you can understand, I will show in the next session some simple experiment what I have done with that. So what happens? This discourages and it brings the centralization problem. So to overcome this only, I said the Ethereum used ghost protocol. However, in Bitcoin, the issue is still there. But you know that the value of the Bitcoin in INR or in your own currency, it's huge, and people are competing to do the mining. And this I was telling, that is the segregated witness. The segregated witness is the one, instead of keeping the signature of the transaction along with the transaction itself, we are going to separate it out, so that when we are computing the block size, it will be considering without that signature part or the segregated witness part. But they found the security vulnerability is like malleability attack. So what the malleability attack is like, we can merge 2 things and it is not possible to identify whether it is modified or not, or it is merged or not. And the reason for this is like they are not following the proper encoding mechanism. And second is, usually the elliptic curve digital signature algorithm is used, and that produces the digital signature as R(S). And this is the signature, and this is also valid signature. If we see the curve, if we see the 2-dimensional array, so let's say this is R(S) and this is R(-S). So these two are the valid signature. So we can take this also or this also. So it is like we'll be computing two values, r comma s and r comma minus s. Definitely any one will be used for the signature, either this or this. But these two are considered as the valid for evaluating the signature. Let's say if we consider this one as the signature, for example, used for signature, and due to the malleability, I can say that with this also I can create the signature or validate the signature. Then what is going to happen? The attackers makes the modification because this is also accepted. So the transactions, whatever is signed as modified one, that is also getting accepted. That will also get accepted as the valid one. So what the solution they give is follow this format, abstract syntax notation exactly, and consider only the signature with smaller s value. So instead of considering both, we can consider only the smaller s value. Don't think in the perspective that this will be like positive and this will be negative, so that this will always be the minimal, because we are going to consider the elliptic curve in the form of discrete. So in those cases, we'll be having the curve points within the region, and we cannot say that it will be having the negative values. And what is the alternate solution suggested is this: when we are creating the segregated witness, we can create a new ID for that. So for every transaction, there will be a transaction address. So we can create a new transaction ID, which is WTX ID. So this will be excluding the signature part. That is, the segregated witness part will not be part of this. So this is also one of the solutions to overcome the malleability attack that is getting created because of the segregated witness. So if we see the attack, there are different attacks possible, but I have represented very few, or placed very few. It's the first one is like Sybil attack. So this is very general in any of the distributed systems because we are allowing anybody. So what the Sybil attack is, I am a single person having so and so name, but I will prove to the public that I am 10%. So I have the body of one person, but I am claiming as 10%. So like a single machine, which is capable of doing a task for single machine, will be claiming as 10 machine, like IP spoofing also. So what is going to happen? Let's say that we are going for consensus based on the majority. Now the same node is claiming as 100 nodes, and it is going to give the vote for the majority. Then what's going to happen? Whatever that Sybil node is going to decide, that is going to be the decision. So to overcome this only, the proof of work protocol is brought into the permissionless blockchain implementation, because if you have the infrastructure for one machine and you are claiming for 10 machine, you solve the problem for 10 users. It is not possible for you to solve because the problem is very heavy. You need 10 times of the infrastructure to solve. If you are going to divide the infrastructure into 10 certain or 10 blocks and you are trying to solve the problem, you cannot solve it. You will be losing. So we can say in proof of work, Sybil attack is not possible. And next is double spending. It is possible the same currency will be spent more than once. However, they have the UTXO, but there are like selfish mining and then race mining or race attack. So those things still brings the double spending, but they are introducing the solutions also. And next is the Eclipse attack, as I was telling in the very beginning, like our neighbors may be colluded as attackers. Sorry. So our neighbors, let's say these are our neighbors, they all are colluded so that they can stop this particular node to connect with the rest of the network. So they decide what I have to communicate, what I have to receive. So transmit and receive, these people can decide. And why such problem happens when I join the network, definitely I will not be knowing people in the network. So what I do is, maybe I will try to contact someone or they may approach me. Normally attackers will come and approach us. So what we consider is, yes, we have the neighbors, so our work is reduced, so we take them as the neighbor. So what is going to happen? They will form the eclipse. So what Ethereum is suggesting, they are introducing the bootstrap nodes. Not only Ethereum, even in Bitcoin also we must be having, because I'm not sure about Bitcoin because I have the implementation set up for Ethereum only. So it's like it contains the bootstrap nodes. Bootstrap nodes address are the address of the developers. So normally developers will not do wrong. So they always suggest you keep at least 7 neighbors. Out of that 7 neighbors, keep some of them as bootstrap nodes. So then the possibility of Eclipse attack is getting overcome. And now it's not now, it is maybe 4 or 5 years or more than that also. Before that also, this concept is introduced, which is called the Lightning Network. So which is considered as the layer 2 payment protocol. So the advantage of this is like, if we have the Bitcoin network and every block is getting confirmed after 10 minutes. That is average block mining time is 10 minutes. So we have to wait. And further also we know to ensure that this will be part of the main chain. Further, we have to wait for another 5 blocks or 6 blocks. So what they have done is, because we want to make the transactions very faster. For example, if we say GPay or any UPI payment, immediately we are making. And if we are going to apply blockchain technology into that, we have to wait for a long time to get the transaction confirmed. So instead of less than a minute, we have to wait for 60 minutes and people will not be appreciating that. So they brought this layer 2 network, that is Lightning Network. It's like person A and person B, again we take Alice and Bob, they will come together and they lock their coin. For example, Alice lock 5 BTC and Bob lock 5 BTC. So it's like up to certain number of blocks, they cannot spend this BTC. After that, they form their light network. And when they are making their light network, that is the channel, new channel get created, and they will be making the transactions. That transactions will not go to the main network for update. So it will happen immediately. In a second, they will be making transactions between them. And when they are making transactions between them, all those are like recorded in both the sides. And later stage, once they say that, yes, let us close this channel, then they will put into the main network. So it will take some time to get confirmed. However, the transactions happen in the Lightning Network very fast. So this is the reason they have introduced. However, there are attacks that are coming like flood and loot attack, but they are giving the solutions for it. So researchers are working to overcome the issues. So this provides instant payment scalability. That means it can make more number of payments in a period of time, and it is low cost. So when we are making transaction in the Lightning Network, there is no need of paying the transaction fee. It's between Alice and Bob. However, the final one, what they are submitting, for that it is required. They have to pay the transaction fee. So this is the difference between Bitcoin and Ethereum. So this I have done some analysis and given here. So let's say Ethereum is also cryptocurrency. As I said, Bitcoin works based on the transaction. However, Ethereum works based on the account balance. So both are cryptocurrency, and this one is transaction based, and this one is account balance based. There is no decentralized application in Bitcoin, but now there are chances they are trying to, and Ethereum is having, we can bring the decentralized application through the smart contracts. And both uses the proof of work. However, now Ethereum moved to proof of stake. So I think last year end they moved. And both these algorithms are probabilistic consensus algorithm. Forks are always possible. The confirmation time average 10 minutes. However, here it is 15 seconds. Fork is possible in both. The waiting time, as I was representing with the probability, it says 7 blocks. Even we can say 6 blocks also. And in case of this, it is 23 blocks. Both are decentralized and there are no authorities and it is permissionless. The Bitcoin is not having the world state. So what the world state is, it's the mapping between the account number and the details. That's the account balance, which is present in Ethereum, so that we can find out the account balance from the recent, that is the latest block, no need to traverse. However, in case of Bitcoin, we don't have that facility. If I want to find the balance, I have to go through all the transactions. So this slide is pending. So this I will take it up in the next session or at the end of the next session. So right now I am stopping here. If any questions, then we will discuss. So please let me know if you have questions. So Dr. Neelam, if I am correct, that this session will be getting over by 12, right?
Yes, yes, yes.
Thank you.
Yes, this session we'll have a brief break of 30 minutes, Dr. Venkatesan.
Yes, ma'am. Yes,
thank you so much for your such a wonderful, excellent talk. And many participants have been writing here about what their questions.
So maybe
I hope.
Shall I take the questions now?
Yeah, if you have a little time, can you please take some questions?
Yes.
And if you don't mind, may I suggest that in the next lecture, maybe after 1 hour, we can have a brief pause, because you will be continuously speaking. So we can have a brief pause where you can also take some questions and take a 5 minutes break if you wish.
Okay.
And so we must thank you, Dr. Venkatesan. It was such a wonderful talk.
Okay.
And participants were asking if PPT share. My dear participants, yeah, we do share the video lectures. So please, please refer to video lectures, which is being live streamed. So please do that. If the speaker also is kindly sharing the PPT, we will definitely share.